So there's three types of bonds in the world: ionic, covalent, and metallic. Metallic bonds are how metal atoms are held together in a solid. So the reason a metal will bond to another metal is because metals hold on to their valence electrons very weakly. They move around. You can think of them as positive ions or cations floating in a sea of electrons, and each cation is attracted to the negative electrons that are floating around it. And that force of attraction between the positive cations and the negative electrons flowing all around all of the cations are what holds a metal together. So in this little animation here, you can see how the positive stationary cations, which are the gray spheres, are kind of stationary, and the negative electrons, which are the red spheres, are floating around them, and they're free to move. They don't belong to any one cation. They might spend some time around their original cation, but because the metals are holding onto their electrons so weakly, those cations are allowing electrons to flow in and out and around from other cations. And this movable electrons, this mobility of electrons, is what explains the three properties of metals. The fact that they are electrically conductive, the fact that they're malleable, and ductile. So they have these three properties. So metals are malleable. That's a word that means they're able to be hammered into shape or bent. They're also ductile, which means you can draw them into wires. You can make like metal wires, like copper wires for electricity. Both of these properties are explained in terms of the mobility of the valence electrons. So let me show you again here. In this little picture, the cations are the red spheres, and they're marked positive, because remember, cations are positively charged ions. And the yellow spheres are the electrons. And now they're not moving in this picture, but they are free to move, and they move around all these different cations. If I hit this block of metal with a force in the direction indicated by the arrow, the cations shift. But because those electrons are mobile, they move with them. They're like kind of ball bearings rolling on, an oiled track. They're just going to slide, and they're going to buffer the positive cations from coming into too close of a contact with each other. Ionic solids are not malleable or ductile. They're very brittle, and this is why. They have cations, which are marked with the positive symbols, and anions, negative ions, marked with the negative. If we hit this ionic solid with force, what's going to happen is I'm going to start lining up positive cations with other positive cations and negative anions with other negative anions. Like charges don't like to be next to each other. They repel, so they are going to break apart, and they're going to fracture on these straight lines like this. And that's why salts, ionic solids, break in these little cube-like shapes that we've seen in other pictures in this video series. So let's remember that metallic bonds are what holds metals together in a metallic sample. The positive cations are attracted to the electrons that are around them. And you can always think of metals as stationary cations with a sea of floating, mobile electrons all around them. If you get a question that asks you anything about the properties of metals, if you can remember this phrase, this stock phrase of stationary cations and mobile valence electrons, you'll probably get the answer right. And it's these movable electrons that explain all of the properties of metals that you need to know. Hope this makes sense, and if you have any questions, please let me know.